Hi guys, today in this video we're gonna see basic formulas that are used in differentiation. First we're gonna talk about how to differentiate constants, then how to differentiate exponents, then logarithmic functions, natural exponent, and finally how to differentiate trigonometric functions. So now we're going to look at how to differentiate if we have a constant in the function. For example, if our function is fx equals 1, what's going to be the f prime of x? If we draw this line, this is what the function basically looks like, and as you can see there is no slope, so the f prime of x is going to be 0. So basically anytime you have a constant in a function, when you differentiate it, it's going to be 0. Now I'm going to explain to you how to differentiate if you have an exponent in your function. Basically if you have y equals x to the power n, your dy by dx is going to be n times x to the power n minus 1. And this is the basic structure that you need to follow when differentiating any exponent. So for example, if we have y equals x cubed, what you're going to do is 3 times x to the power 3 minus 1, which is basically 3x squared. And now I'm going to give you another example which looks slightly different, but it's again basically the same principle. So we have y equals x to the power half, and what we do is again dy by dx equals half times x to the power half minus 1, which is half x to the power minus half. So if we have y equals the fifth root of x squared, the first thing we want to do is make it look a little less scary and write it as an exponent. So it would be x to the power 2 over 5. And then again, it's the same thing that we did in the previous example. So dy by dx equals 2 over 5 times x to the power 2 over 5 minus 1, which is 2 over 5 x to the power minus 3 over 5. And that's basically how you differentiate exponents. Okay, now we're going to look at how to differentiate a function if it has a logarithm in it. So if you have y equals log base a times x, the general formula of the differentiation is 1 over x times ln of a. And I'm just going to put this in a box because this is the basic formula. Now that we know the general formula, I'm going to give you an example and show you how to apply it. So if we have y equals log base 2 of x, then dy by dx is going to equal 1 over x times ln 2. So in this case, the a is 2 and x is just x. From this, we can actually find how to differentiate the natural logs, and this also comes from applying this formula. So I'm just going to show you how that works. So if we have log of base e, which is basically ln, the natural log of y equals, then we get dy by dx, which is 1 over x times ln of e. And we also know that ln of e equals 1. So this becomes 1 over x. And this is also important because every time in an equation, if you see ln of x, so if you have y equals ln of x, the derivative of that will always be 1 over x. So now we're going to look at how to differentiate natural exponentials. So if we have the function y equals e to the power x, the differentiation of that is also going to be e to the power x. But if we have a more complicated function instead of x, so for example x squared or 2x, then there is a different rule that applies, and we're going to explain that in the following video. Okay, so the last set of functions that you need to know how to differentiate are trigonometric functions, and I'm going to give you the basic rules that you should remember. So if we have y equals sine x, then your derivative is going to be cos x. And this is what you need to know. And then if you have y equals cos x, your derivative is going to be negative sine x. Don't forget the negatives because sometimes people forget, and that's important. And finally, if we have y equals tan x, your derivative is going to be 1 over cos squared x. And now I know this looks a little bit different, but that's because if you can remember, tan is equal to sine over cos, and so sine x over cos x, and differentiating this is different because it's a quotient of two functions, and we're going to explain how we do this in the next video.